So let us start. Let's continue with the next objective, and that is how to describe changes of state in terms of melting, boiling, evaporation, freezing, condensation, and sublimation. So what is change of states? So when we say change of state, we are referring to the process by which matters change from one state. For example, we said matters can be they can be in any of these forms. They can be in liquid form, they can be in solid form, they can be in gaseous form. So the three states of matter we mentioned them already. So it is possible, for example, like water, we have water in form of ice, we have water in form of water that is liquid, which is, I will call it water, and we have water in form of steam. When I say water in form of ice, I mean in the state of solid. And when it is water, the way we know it, that is, it is in liquid state then. And steam means water in gaseous form. So what governs the changes? The changes that happen to water, what makes it to change from ice to water to steam? So the process of change of state is governed by only one factor, and that is a change in temperature. Change in temperature of the matter. When I say change in temperature, I mean supplying heat or heating or remover of heat or cooling. So heating or cooling means change in temperature. So if any of this happen to a matter, it can change. Matter can change from any of its states, whether from solid to liquid or to gas. So whenever there is change in temperature of a matter, when temperature of a matter changes, what will happen is that matter can undergo any of this process. Number one, it can melt, it can undergo melting. Matter can undergo boiling. If we change the temperature of the matter, it can undergo evaporation. Matter can undergo freezing. It can undergo freezing, and matter can also undergo sublimation process. Sublimation process. So remember I said if we change the temperature of a matter, any of this can happen to the matter. So let's take them one by one. So we'll start with melting. What is melting? When a solid is heated, as I said, when a solid is heated, its particles gain more energy and vibrate more. It's just like when you are in a room and they set the room on fire. It means you get more energy instantly. You will not even know where the energy comes from. Just run out of the room. So that's what happened to matter. We can just liken it to something like that. When a solid, if you have a solid like this, we have this as our solid. Just wait for me. So let's say we have our solid with these particles inside it. So the particle has to be arranged in order, of course. It has to be in order. So let me just to make it faster in order not to waste our time. Let's just say, let me draw it instead of just making it that way. So we have our matter like this, our solid. If this is solid, of course we know that it contains particles, and those particles are arranged this way. They touch each other. So we have it like this. Okay, so that's the particles inside a solid matter. So when this matter is heated, if this solid substance is heated, so I use this as a sign of heating. So if you heat this, what will happen is that these particles, they will gain more kinetic energy. The particles, they gain more kinetic energy. These particles, they gain more kinetic energy. So it means when we say kinetic energy, we remember energy due to motion. So it means that they vibrate more. So when they gain more kinetic energy, the particles will vibrate more. They will vibrate more. Vibrates more. So when the particles vibrate more, it means this particle, they will expand. Vibration will make the particles to expand. So the vibration will make the particles to expand. So it means this particle, they will change from this state let me take this. So we change from this form, and then it's become expanded. It becomes expanded, something like this. Let's see it as something like this. So not that they become bigger, actually. The particles, they become the solid particle, that solid become expanded. So if you keep heating it, that is, if you keep applying the heat on the particle, you heat this one, it expand, and this one still heat this, continue to heat this, still apply more heat on this. It will get to a point. Remember, when the particles, when they are vibrating, well, as you increase the heat, the vibration will increase. So remember, what binds these particles together, we said, is a force of attraction. So it's like you are shaking that force as the particles are vibrating. So the next thing is that the force will break. That force will break. So at that point, when the force break, it means we say the particle has, or the solid has reached its melting point. So that is the melting point of the solid. You know what will happen? So what will happen is that the solid will become liquid. So it means what binds them together, what binds the particles together, will no longer be there, and the particles will not touch each other any longer. So it will look like this. Of course, when they don't touch each other, when they melt, it means it has become a liquid at that point in time. So you have the particles like this now. You can see that they are not touching each other now. They have some little spaces in between one another. So it means it is no longer a solid matter. It is now a liquid. So it means that substance melts. That solid substance melts then. So remember, I said when you apply heat, the heat will increase, the particle will gain more kinetic energy, and they will vibrate more. When they vibrate more and you still keep applying the heat, then it will get to a point that the force of attraction that holds the particle together get weakened and it breaks. So at that point in time, we will said that solid substance melt. That is melting. Melting happens when the particle expand and it vibrates to the level, to the extent that the force of attraction between the particles breaks. So at that point in time, that solid will become a liquid. So this is a liquid substance now. This is a liquid substance. So the substance, the solid melts, and become a liquid. So this process is melting. It is melting. Of course, you know what leads to melting now. Okay, so what about boiling? What about boiling? So this one will happen to liquid. Liquid boils. Solid does not boil. If solid has to boil, it must pass through a liquid stage. So melting is to solid, while boiling is to liquid. So I take my liquid here. I take the liquid. It is just a liquid. This is our liquid, and if you apply heat to that liquid again, if you keep on heating the liquid, what will happen is that those particles, of course, they have kinetic energy already. They will still gain more kinetic energy. So the particle gain more kinetic energy. Heat makes the particles to gain more kinetic energy. Control. So I say particles gain more kinetic energy. And what happens if they gain more kinetic energy? It means that they will move faster. So the particles move faster. They move faster. So what's the next thing? Then when they move faster, it means they have to be colliding with each other more. They collide with each other. They collide with the wall of the container. They keep on bouncing and they move further apart each other. Then the next thing is that the liquid too will expand. The liquid will expand. So when the liquid expands, because the particles they've gained more enough kinetic energy for them to expand, they will expand. So when they expand, all the forces of attraction, the remaining forces of attraction that is still holding the particles of liquid together, for them to have these little spaces, that force will break completely. So that force will break. They will overcome the force completely. So when they overcome that force completely, the next thing is that the particle, they start to escape. So when particles start escaping, we will say the liquid is evaporating. So they form a gas at that point in time. So let's draw that when the particles start. Evaporation and boiling, they are very close to each other. So remember I said they gain energy, they move faster, then the liquid expand. At that point in time, they have to be moving around. When they are moving around, bouncing, of course, when you are boiling water, you can see that. You will see that the particles, the bubbles keep on moving around. It's something like that. So because they've gained enough kinetic energy. But if you still keep on applying heat, you are still heating them, something like this will happen. So you have, let me draw it this way. You have it like this. I draw it in form of a container now. So you have the particles like this, particles of liquid, and that is boiling already. So you still keep on heating. What happens is you will see some of those particles, they will escape. They will move out. So when they escape, we will say the particle or the substance evaporates. The substance evaporates. So evaporation happens. It happens when particles have enough energy to overcome the forces of attraction that is holding the particles of liquid together. So evaporation can happen not only when you increase the temperature. So remember, I've moved away from boiling. I'm now talking about evaporation. They're very close to each other. So this process is like a mixture of boiling. It is boiling. I would say boiling slash evaporation. So this is evaporation. That part on top is evaporation, and you know the reason why it happens. Okay, so what I'm saying is that evaporation may happen and just take note that it may happen. It happens at all temperature. Doesn't matter whether the substance have reached the boiling point or not. Boiling point means the temperature at which the liquid starts to boil. So it doesn't matter whether the boiling point is reached or not. So far, the gas can get enough energy to escape, that is to break away from the force of attraction and then escape. So when it escapes, we say the gas, the substance evaporates. So that's why when you just if you drop some water on the floor, if you have some water on the floor, you leave it for maybe a few hours or maybe in a day, 24 hours, you will see that that water is no longer there. The water, without boiling it. So the water had gotten enough energy. The particles of that liquid of water, some of them, all of them, they've gotten enough energy for them to escape the liquid. So at that point in time, we said the liquid evaporate. So that is about evaporation, boiling, and as well melting. So the process that we just mentioned now we talk about melting, we talk about boiling, we talk about evaporation. These processes, remember, they can be it can be reversed. So you can reverse that change. That is, if you have a solid, let's look at it. We have solid. Remember, my note up here means I said evaporation happens at all temperature. So I was talking about reversing that changes that we just mentioned. That is, solid can melt. So we have a solid like this. So solid can melt. So for example, ice, it can melt and become water. It becomes a liquid. So I use ice as an example here. I say ice, I say water. So liquid can also continue. So we are trying to raise the temperature. For example, the temperature is like 0 degrees centigrade here. So you keep on. When it melts, it becomes liquid. And then liquid will now evaporate. It now evaporates and become So how can we reverse this process? So it is very simple. We start from solid. We start from solid, and we use we say solid, and we use ice as our example. Ice. So ice can melt. Ice can melt. It can melt at 0 degrees centigrade. At 0 degrees centigrade. So when it melts, it becomes a water. That is, solid can melt to become liquid, which is in form of water. This time around we're using water as our example. So as we keep going, if you keep warming this water, if you keep warming the water, so I say as it warms, so some of them will evaporate, some evaporate, that is, some of the particle will go out. So I say some evaporate, so some evaporate, and the rest boils at 0 degrees centigrade. The rest boils at 100 degrees centigrade, not 0 degrees centigrade, and the process continues. So after that, what do we have? We are going to have we will have steam. Oh, sorry, let me make it better. We will have gas. We're going to have that is, the liquid will turn to gas, and the gas, water in gaseous form, is called a steam. It's called a steam. So this process can be reversed. That's what I'm saying. We can reverse this process. So let me take the same image. So let's see how we can reverse this process. So there is a process here. So how can we get it reversed? Don't mind me, please. So let's take, so the steam, this our stream, can also cool. So I will erase this. I will erase this now. So as you cool, I will say, as it warms, now as it cools, this is the reverse process. So this will be where the arrow will be now. The arrow will be here now. So as it cools below 100 degrees centigrade, what is going to happen to the water? The water vapor, that is the steam here, the steam begins to condense. It begins to condense. So remember, we have to remove this arrow. So we are trying to draw the opposite of what happened over there. So when the gas cools below 100 degrees centigrade, the steam will begin to condense and become it will begin to condense. Of course, condensation will make it to become water. To become water when it starts to when it condenses. So then, if you keep on, if you keep cooling it, you just continue cooling it. So this process here will change now, and this arrow will not be there. So I will change it to this side as well. So to show that it is the opposite. So what happens is that the liquid water or the liquid will freeze. It will freeze, that is, it becomes solid. We call it solidification. So it solidifies. You can see everything happens that we don't change the temperature, just it moves up. It moves to the right direction when you increase the temperature. So I would say, for us to understand it better, the process on top here, the process here is pointing towards heating. This one is heating. All the process here means you are heating the solid, and the backward process here means you are trying to cool the gas. So this is cooling of the gas. So remember, it means melting and freezing happens at the same temperature. A solid substance will melt to become liquid at 0 degrees centigrade, while a liquid substance will also freeze to become solid at 0 degree centigrade. Same thing happens here. A liquid will evaporate and turn to gas at sorry, I'm talking about water, please. I'm talking about water. Ice will melt at 0 degrees centigrade to become water, what is a solid. So also liquid, which is water, will also freeze, or it freezes at 0 degrees centigrade to become ice. Also, water evaporates it boils at 100 degrees centigrade and then evaporates to become gas, that is to become steam. Also, gaseous water, which is a steam, can also cool down. It begins to condense. It's cooled down from 100 degrees centigrade, and it becomes water at that point in time. So it starts to cool from 100 degrees centigrade, and it becomes water at that point in time. And also liquid water also freezes. It freezes at 0 degrees centigrade to become ice, which is a solid form of water. The summary of this, summary of what I'm saying is that melting and freezing, melting and freezing happen at the same temperature. At the same temperature. If a substance is pure anyway, temperature. Also evaporation and condensation. Evaporation and condensation begins to happen at the same temperature. So please take note of that. It is very, very important. Thank you.